Hi, this is the Start 3D Modeling channel, and in this video I will show you how to create this part in Onshape. Onshape is a CAD system that runs in a web browser. The advantage of Onshape is that we can launch it on various devices. We can work on a laptop, a desktop computer, or a tablet. And if you want to test Onshape, you can find a link to the program in the description below this video. Now I will go to Onshape and show you some basic operations for creating 3D solids in this system. I have a new project running, and here we see the coordinate system planes and the origin. We can turn this visibility on or off in the feature list. We have the eye icon here, and we can simply turn off the visibility of selected planes. I have turned off the visibility of the front and right planes, and we will start by creating a sketch on the top plane. That is why I am not turning off the visibility of this plane for now. I select this plane and choose the sketch command to create a sketch on it. Now, to switch to the normal view of the sketch plane, I press the N key on the keyboard. Here, we will start by creating a rectangle. I will choose the center point rectangle command to specify the center point of the rectangle. I want to constrain the center point of the rectangle to the origin point of the coordinate system. Therefore, I hover the cursor over this point and left-click to constrain the center of the rectangle to the origin point. Now, we left-click to define the position of the rectangle and enter the dimensions. For the first dimension, enter 150 millimeters, press Enter, and for the second dimension, enter 80 millimeters and press Enter. In this way, we have created a rectangle with dimensions of 150 millimeters by 80 millimeters. The rectangle drawing command is still active. We can create more rectangles. I press the Escape key to cancel this command. I select this rectangle and press Delete to remove it. Now, based on this sketch, we will create a solid by extruding the sketch. I close the sketch. Here, as you can see, the top view is set. To change this view, to rotate it, we hold down the left mouse button and can rotate the view. For zooming in and out, we use the mouse wheel. And for panning the view, we press the mouse wheel and move the view. Okay? Now, based on this sketch, we create a solid by extruding the sketch. We select the extrude operation. The sketch for the extrusion is not selected. So we click this area, and here we specify the extrusion depth. Enter 30 millimeters here and press Enter. We accept the operation, and in this way, we created a solid by extruding the sketch to a height of 30 millimeters. Now I can turn off the visibility of the top plane. This plane is not needed right now. And now we will move on to the next operation and create fillets on the corners of the solid. To do this, choose the fillet operation and select the edges to fillet. We left-click on the edges we want to fillet. We select these 4 edges. When selecting these geometries, we simply left-click. At this moment, we do not need to hold down the Control key or the Shift key. We simply left-click to select these edges. We can change the radius value using this arrow. Or we can simply enter a specific value here, enter 30 millimeters here and press Enter. We accept the operation, and in this way we created the fillets on the corners. And now we will move on to creating holes. Regarding hole creation, we have the hole operation here, which allows for creating standard holes. However, in this case, we will approach this by creating the holes based on a sketch so that it is done as simply as possible. Therefore, we will create a new sketch on this face. When it comes to creating sketches, besides creating sketches on one of the basic coordinate planes, we can also create sketches on the faces of the solid. A solid face can serve as the sketch plane. To do this, we simply select the face and choose the sketch command. Now, this face is the sketch plane. We press the N key to switch to the normal view of the sketch plane. And here we select circle drawing. Choose the center point circle command. And here I would like to place the center of the circle at the center point of this fillet. As you can see, when I hover over this fillet and then hover near the center point of this fillet, a snap appears here, and we also have a constraint icon. This means that if we click here to place the center of the circle will be constrained concentric to the fillet. I left-click, then I left-click again to specify a point on the circle, and for the circle diameter, I enter, for example, 12 millimeters and press Enter. Now we will create circles in the remaining corners of the solid. We hover over the fillet to locate that point, and this time let's create circles with arbitrary diameters. For now, we do not enter the diameters of these circles. we simply create these circles in the same way so that the centers of the circles are constrained to the center points of the fillets. Now I press the escape key. I deliberately did not dimension the remaining circles because we will define the dimensions of the other circles using a constraint. That is, we will assign a relationship to these circles so that their diameters are equal to the diameter of this circle. This has the advantage that if we need to change the diameter of these circles, changing the diameter of just one circle is enough, and the other diameters will adjust accordingly. To do this, we choose the equal constraint and select the circles that are supposed to be equal to each other. We select pairs of circles to constrain them sequentially. Now I press the escape key to cancel this command. And now this has the advantage that if I now change the diameter of this circle, to do this, I double-click here with the left mouse button and enter 9 millimeters as the circle diameter. The diameters of the other circles are also changed. We close. And based on this sketch, we will create holes in the solid, and we will do this using the extrude operation as well. This time we can select these 4 areas based on which we will create the holes. We select them simply by left-clicking. We choose the extrude operation, and by default, a new solid feature will be created here. But to remove material based on the sketch, we switch here to the remove option. Now material will be removed from the solid based on this sketch, and here we have a specific depth for this cut. In this case, these holes will be made to a depth of 25 millimeters, but I want these holes to be through all. Therefore, I expand these options here and select through all to specify that regardless of the solid's height, I want these holes to be through all. I accept this operation, and in this way we created holes in this solid. And now I will show you another advantage of Onshape. Onshape is a parametric CAD system, and such systems work based on features and parameters. If we need to make any changes, we do not have to create the entire model from scratch. It is enough to change the selected parameters. In this case, I would like to change the fillet value. To do this, I double-click this operation with the left mouse button, and here I change the radius value, for example, from 30 to 15 millimeters. I accept this operation and notice that the hole position has also changed because the centers of the circles, based on which these holes were created, were constrained to the center points of the fillets. So as you can see, if we are designing parts, especially those based on which we create a physical product, it sometimes happens that after manufacturing the first unit, something still needs to be changed. Some corrections need to be applied to the model. And thanks to the fact that we have parametric CAD systems, we do not have to create the entire model from scratch. We simply introduce changes to the selected parameters, and the model will be updated according to the changes made. Of course, this is not a feature unique to Onshape. Other parametric CAD systems can also do this. Even the completely free FreeCAD handles this well. I want to emphasize that if you want to create parts with regular shapes and you manufacture physical products based on the models, and sometimes you find that after manufacturing the part you need to introduce minor changes, parametric CAD systems greatly facilitate this. And okay, now we will move on to the next operation and create more holes. And we will also do this based on a sketch. We will create a sketch on this face. That is, we select this face and choose the sketch command. I press the N key to switch to the normal view of the sketch plane and select circle drawing. And just like in the previous case, I look for a snap here that will constrain the center of the circle to the center of the hole. When this snap appears, I left-click, then I left-click again to define the second point of the circle and enter the diameter of this circle as 15 millimeters. And I draw the remaining circles in the other holes. This time I do not specify the diameter of these circles, I just draw these circles freely. I press the escape key to cancel the circle drawing command. And now I select all 4 circles. I simply left-click on these circles and choose the equal constraint. We can apply the equal constraint in this way too. All selected geometries are equal to each other, and this has the advantage that if we need to make any changes here, the diameters of the remaining circles will also be changed. Okay, we close the sketch, and based on these sketches, based on these areas, we will create holes in the solid. I select these 4 profiles. choose the extrude operation, switch to remove, and specify the hole depth, for example 15 millimeters. I press enter and click this button to confirm, and in this way we created subsequent holes in this solid. Now we will create another sketch based on which we will remove material from the solid. We will also do this on this face. We select this face and choose the sketch command. I switch to the top view of the sketch plane and select rectangle drawing from the center. I place the center of the rectangle at the origin point. As for the second corner of the rectangle, I would like to constrain this corner to the edge of the solid. Notice that when I hover over this solid edge, the coincident constraint icon appeared. So if I left click on the edge of the solid now, the corner of the rectangle will be constrained to that edge. And regarding this dimension, I can no longer change this dimension because this dimension results directly from the solid's dimension. And now we can change this dimension. To do this, I hover the cursor here and enter 80 millimeters as the value for this dimension and press enter. As for this dimension, the edit field for this dimension is now active, but notice that if I enter a different value here, an error will appear. We cannot do this because this dimension is a resulting dimension and derives from the constraint. I select this dimension and press delete. Of course, if I had not defined this dimension while drawing the rectangle, if I hadn't typed anything there, this dimension simply would not have appeared. I just wanted to show you what happens. And now I will create a second rectangle in a similar way. I place the center of the rectangle in this location. I place the corner of the rectangle on this edge. And now I could define this dimension, but I will not define it. I hover the cursor over this dimension, and here I enter 20 millimeters as the dimension value. I press enter, then I press the escape key. As you can see, I did not enter this dimension. This dimension did not appear here, and the rectangle is black. Black geometry means that the geometry is fully defined. That is, this geometry is fully constrained. We cannot freely change the dimensions and position of this geometry. Now, for example, I will create another rectangle. I do not define the dimensions of this rectangle, and notice that I can freely change the position of this rectangle, and I can freely change the dimensions of this rectangle. I select the rectangle, press the delete key to remove it, and here we have this sketch. And now, based on this sketch, we will remove material from the solid. I close the sketch, and here, to remove material from the solid based on the entire sketch, we simply have to select these areas. We could prepare this sketch in such a way that it is one single area, but it will also work if these areas are not single areas. In this case, we simply have to select these 4 areas, and we can remove material from the solid based on these areas. Alternatively, I will show you now how to edit the sketch and how to make this sketch one single area. To edit the sketch, we go to Sketch Editing. We double-click the sketch with the left mouse button. And here we simply need to trim the geometry segments. We have the trim command, and we select the geometries we want to trim, and then we close the sketch. And in this way, we introduced changes in the sketch. This is how you can edit sketches. You simply double-click the sketch you want to edit, and now this area is a single area. We choose the extrude operation. Here, we switch to remove and specify the depth of the pocket, for example, 10 millimeters. We press enter and accept this operation, and in this way, we created this solid. Now we will add chamfers to the edges. To add a chamfer, we choose the chamfer operation and select the edges we want to chamfer. In this case, select these 4 edges. And here, enter 10 millimeters as the chamfer dimension and click OK to accept it. Next, choose the chamfer operation again. Now, we will select more edges. Okay, and here, enter 5 millimeters as the chamfer dimension. Okay, regarding chamfers, we can also add chamfers based on the faces of the solid. In that case, all edges of the face will be chamfered. We select the chamfer operation and point to the faces of the solid. And here, enter 1 millimeter as the chamfer dimension and click OK to confirm it. And in this way, we created this solid with these few simple steps. And as I mentioned before, Onshape is a parametric system. meaning we work here with features and parameters. Modeling is based on the feature list. Every operation we add is saved in the feature list, and we can go back to every operation at every stage of 3D modeling, and we can change every operation. For example, I will go to the first extrusion and change the length of this extrusion, for example, from 30 to 35 millimeters. I accept the changes, and the changes have been applied to the model. And notice that the holes are also through all. The solid is 5 millimeters taller, but these holes are through all because when creating these holes, we selected the through all option, which specifies that regardless of the solid's height, these holes will always be through all. Regarding changes in sketches, we can do that too. We double-click the sketch we want to edit with the left mouse button, and for example, I will change this dimension from 150 to 250 millimeters. I click OK, and the changes have been applied to the solid. So, as you can see, this is a major advantage of parametric CAD systems, and we will finish here. Thank you for watching, and please subscribe to this channel.